Hey, it's Evan Reese, and we are here in part 5 of our input field series for Onshape, going through all of the magical feature script codey things that you can do in any input field in a feature or a sketch dimension in Onshape to add logic to your designs. And in this video, we're going to take all of the tricks and tips that we've learned from the previous 4 videos. So if you haven't watched those, start there. Don't be weird. But in this video, we're going to take all of that and wrap those bits of logic up into reusable functions that you can use across your organization. So let's get to it. Okay, but first, what is a function? In code speak, a function is a set of logical operations that you're going to perform on a set of inputs to give you a set of outputs. So we've already used a ton of functions. We used the absolute function. You should in the variable feature. If I come in here and say that this is going to be called abs, if I use ABS here and give it -6, it's going to return +6 because the absolute function always returns a positive number. So the one argument here is -6, but it could be also 5 and it would still be a positive number. It doesn't matter. Also, sine is a function. You can give it an angle, 30 degrees, and it's going to give us, 0.5 in that case. So it's a ratio. It returns a ratio. The tangent, which we've already used in previous videos, is also a function. And so a lot of these things, they're functions. We've already used them, but we can declare our own functions for things that don't exist here. So we can set up our own logic. And let me show you how that might work. If I instead make this I'm going to call it double. And I'm going to make a function that just takes in any number and returns a number twice as big. So to do this, let me show you the syntax first. I'm going to type the word function, open and close parentheses, and then we have open and close curly brace. And inside of that, I have the word return. And this is the keyword that's going to tell feature script everything after the return and before the semicolon is what you actually produce and give back as a result. So there's a semicolon in here. Okay, now look at that. I've got a big space in here. The double enter gave me a period I don't need, but this space right here between the word return and before the semicolon, that's where our function is going to go. And in here, this is where our arguments go. And you can have more than one. The arguments is just the codey word for the inputs to the function. So in this case, I'm going to have one input. Doesn't matter what I call it, as long as I call it the same thing in the return part of the function. So x doesn't matter. And for the return, I'm going to say x times 2. That's it. White space doesn't matter. It really doesn't, but I'm just going to clean it up. Okay, so now I have this, and it says I have a function here in this variable. It doesn't tell me what it is or anything. So actually one tip for you is I like to take at least the formula part, but actually really the whole thing, and just paste it into the description. This helps me because, if you have 4 arguments, you may not remember offhand which order they go into here or anything. So, and I suppose it may not matter. Yeah, no, it does matter. So anyway, now when I mouse over it, it shows me the contents of the function. So if I'm declaring a function, that's what I'll pretty much always do, put it in the description here. Okay, so let's try this thing out. I've got this cylinder driven by my variable called height. So if I want to extrude a second cylinder, and I can do this by, see if I start to type double and hit autocomplete, we get the hash, and then it also has the braces here, and this is where I put my argument. And the number I want to double is height. And so now the one on the right will always be double the one on the left. And it doesn't have to be double. It could be, per some very subtle relationship times pi or whatever. So, we can set up functions like this. This is a basic example. And the beauty of this is that it can be reused. So if I had another extrude and another thing that needed to be related to this ratio, I don't have to put this same math in there again. I can just use the function. So that's the beauty and benefit of using a function is usually to reuse a set of logic that you're going to use over and over again. You find yourself doing the same kinds of things over and over again, copying and pasting code. You can just use a function to do that. Now, this is where I got to call out one bummer or gap of this right now is that they don't work in a variable studio, which is the place where they would be the most useful. It loses a lot of utility because you have to declare it in a feature in the part studio you're working in. So Onshape devs, if you're watching, like, this is where functions belong, and they really need to work here to be useful in an organization. So if your organization makes a ton of helical gears, then maybe you would have a helix angle function here, and you can put this into any part studio in your whole organization, and everybody on your 100-person team can use it. You can actually start to get some pretty big value out of it. At the end of the video, I will show you how you can package them up using actual feature script and drop that at the top of any studio that you want to use it in. But it's not quite as clean, and I would really love to see this implemented in the variable studio. Okay, so that's a function, and actually the helix angle is not a hypothetical. I have an example of that here, and I want to walk through how we might set that up and how I might make sure I know what formula I'm using. Let's see, start angle, pitch. I'm going to say turns and pitch here because I just want one rotation. Okay, so here's my helix, and I have defined it by the number of turns, which is just one loop around, and the pitch, which is the distance from here to here. That's the pitch. So if we wanted to drive this, instead of by the pitch, we wanted to drive it with helix angle, we need to find a way to convert between the two. And just for the uninitiated, the helix angle is this angle right here. If I were to continue this line as a straight line down, where does it meet here? So I'm going to talk briefly through how you can, like, the logic of that function, a little math side note, and then we'll talk about how you might get it if you're not feeling up for solving it yourself. So to think about the helix angle, if we have to think about this is the line that we're going to use, but we want to unroll it. So actually I have an example of that here. Like, if we unrolled that helix, this is that helix unrolled, and this is this base circle unrolled. So you can see we've defined a triangle, and wherever there's a triangle, there is trigonometry. So we're trying to solve for this. This is the pitch of our unrolled helix, and so this is x. We already know this length because we know the diameter of our helix, and this is going to be the circumference, so diameter times pi. And then we know this angle, because that's one of our inputs. That's the helix angle that we're going to use to drive everything. And so we just have to solve for this. And if you're remembering your trigonometry, you'll know that the tangent of an angle, so this angle, the tangent of that is going to be equal to this number over that number. So a little bit of algebra. Well, let me just show you the algebra. Okay, so our equation looks like this. We have the tangent of our helix angle equals opposite over adjacent. So in order to solve for the opposite, we remember is x. That's our pitch. That's what we want to solve for. And the adjacent was our circumference. So to get this, we can multiply both sides by circumference. So this gets moved up here. Cool. So that's what our equation, that's what our equation is going to look like. Get rid of that. So in order to get the pitch, we need the helix angle times the circumference, and the circumference is equal to diameter times. So there we go. That's the equation we're going to use to solve for the pitch based on helix angle. And that looks like this. We already laid out this function. I'm just going to refresh you on the format here. So we've got the keyword function that tells us we're declaring a function. I've got an open parenthesis, and then inside of here I have two arguments this time. Helix angle separated by a comma, and then diameter. So those are the two inputs. And for any helix, if I give it these two things, it will give me the correct pitch. So now I've got an open brace, the word return, that's our keyword. And then anything between the word return and this semicolon, that is the actual operations, the logic of the function here. Diameter times pi times the tangent of the helix angle. That's the equation we just came up with. Then we've got our semicolon and a closeout on the curly brace. So that's our function, and it's declared. So now inside of the helix here, let's see, the pitch. Yeah. So to get that, I'm going to stretch this out. So here, I've already got a diameter up here, and I've already got a helix angle here defined as variables. So I'm just putting them into the correct locations for that argument, and it is producing the pitch for us. So now we're getting this helix that matches the exact helix angle that we want, and the diameter can change, but the angle of the helix will not change. There you go. So that's actually a fairly believable example. I will say, like, I say it's believable. I don't think there are a ton of use cases, especially without them being available in Variable Studios. There's not a lot of use cases for functions here, but I wanted to be very thorough and complete in the information that I'm sharing with you, because I don't want to tell you what you will and won't be able to use. I actually want to hear how you end up using this. So let me know in the comments if you end up using functions like this. I've used them sometimes, but it's not super common. But I do feel that for certain industries, being able to establish a set of common logics and wrap them up into functions could be really valuable. That's me going through all this algebra, and maybe that's really not your bag. It's not everybody's thing. You know, I kind of like math, especially geometry, but I hit my limit as well. So the great thing about math is it's been pretty well documented and established, and that means that LLMs are good at it. So they don't always get the math right, but they can do the research and they can figure this stuff out, and they're getting better and better every day. So I want to show you how you might come up with this formula yourself without having to fully research and understand it, although I encourage research and understanding. Let's just take a look at what we can do to get this with an LLM. And I'm going to start by trying Onshape's AI Advisor. Now, this is here to mostly help answer questions about Onshape, and it is trained on a super narrow data set. And a lot of times, if you ask it for something that's outside of that set, it'll say, I can't answer that for you, you know, submit a support ticket, or, you know, do your own research or something. But it has worked for me a little bit to get functions like this. So I'm just going to try it, and it may work, it may not work. And then after this, we'll go compare it to GPT, which I feel more confident in. But there's a lot of convenience in having an AI tool right here in the flyout. So let's try this. All right, I've got this prompt for it, and we'll see how it goes. I'm creating a function to use in a variable feature, not a feature studio. And I'm clarifying that to the LLM because I don't want it to add any of the other kind of code stuff it might be used to, like commented lines explaining what it's doing and all that. I want it to be just tight and compact. We'll see how that goes. And then I say that should return a helix pitch from the inputs of helix angle and diameter. Create that function so that I can copy and paste it into a variable feature. Okay, here goes nothing. All right, I got it right. The helix pitch can be calculated using the formula pitch equals pi times diameter times helix angle. Here's a function that calculates it. No, this function is bogus. There is no math.py or any of these things. It's referencing other scripting languages, which is wild. But it got the formula right, so maybe that would be enough to get you going. Okay, let's go try GPT and see how that goes. I'm going to give it the same prompt. I'm going to add the word in Onshape since it is no longer implied, and we'll see how it does. I've already talked a good bit to GPT about various feature script things, so I think I may have more context than just a blank instance would, but let's see how we do. Yeah, this is formatted for a feature studio, so it didn't understand what I was saying about doing it in a variable feature. But again, this is all the right anatomy. So if I were to copy and paste this, this one has a comment that I would need to get rid of, and it has these like declarations to tell you what type each input is, and you don't need to do that in the variable studio version or the variable feature version. But otherwise, this is right. I mean, this is on a new line, but if you just get rid of the new lines and put, you know, the curly braces all in one line, this is the correct formula. So you can get it to do more complex things, and I'll show that some more in a later video too. Okay, so yeah, I guess the upshot there is use LLMs like they're good at knowing where to look to create more complicated forms. All right, one other example, and this one is a stretch. I'm going to go ahead and say it. I think this is me seeing what's possible and showing it to you. But in reality, to accomplish this task, I would really just make a custom feature, which is also what I've done here. But let me just talk you through the thing I was trying to accomplish. I wanted to create a function that, when given a chain size and a tooth count, will return the outer diameter of the sprocket that goes to that chain and that gear, so that we can drive the size of this circle. So let me just show you what we're working with here. I'm going to check the final button. The chain size is actually a string. It's not a number. So there we go. If I change it to, well, that failed because I guess maybe I don't have that size and tooth count pairing set up. Let me try 40. Yeah. And then I can also change the tooth count and change the size of this circle for that size of chain. This could be useful, but setting it up using only variable features and not using any actual, like a variable studio, might be kind of the wrong way. Let me show you how I got here. Once again, I used ChatGPT to process all of this and to produce tables that look like this. And what I did was give it this URL. I just found some tables that have the information that I'm looking for online. And then I gave it this URL, and let's just see what we get here. All right, I've said take the tables of sprocket sizes from this site and gave it the URL and convert it to a set of nested maps for feature script, each key value pair on a new line. So let me unpack that. We remember maps from the containers version, and a nested map means that the thing you get back from the first key is another map with more keys and values inside of it. So because this is a table, what we're looking at is we're going to have a first set, the key will be 25 or 35 or 40. And then inside of that will be a map with the keys 9, 10, 11, 12, and those will return the final value. So that's what I mean by a nested map. Let's see if it knows what I mean. Look at that. It's just cranking it out, and I don't have to handle all of this formatting. I think one of my favorite uses for AI with code these days is just to reformat information. I could literally give it a screenshot of these tables and it could produce a format like this that I can actually use. So I'm gonna hit copy code and come back here. I'm just gonna make a new feature studio. This is what I would be doing if I were doing it from scratch. And I'm just gonna paste it in and see what we get. So yeah, it's exported it as a constant. This is my map. And then if you're going to reference something like this, go ahead and do yourself a favor and comment in. You can use two slashes like that to create a comment. Just put the URL because you're going to want to know where you got the information from. If there is a mistake in here, which is not impossible, then you want to be able to know what the real source of truth ought to be and where to repair it, and all that. And it's also just good to cite, if you're borrowing someone else's information, it's good to cite it. Okay, I'm going to copy and paste this whole thing. And in order to do that, I'm actually just going to collapse this whole row. And I'm going to grab this brace to that brace. I don't need the semicolon. All right, so I've copied that. And I could have just copied, I could have also done it from here inside of GPT. That would be also valid. Just take that, don't need the semicolon. Let's just do it that way instead. Okay, so I'm back here and I'm in my sprocket table area. And here is where I put that table before. Let's just see, I'm going to put in the new one. Look at all that data. I'm going to put in the new one and see what we get. If it causes any problems, something's wrong already. Is the first key missing? Let's go on a troubleshooting journey here. For one, it's added this symbol to the keys, which I didn't have prior. It's actually probably more accurate to include that. But maybe it doesn't like seeing that symbol. What happens if I get rid of it? Yeah, that's it. So for some reason, the hash is messing this up. So I'm gonna get rid of that here. And I need to get rid of all of them. So I'm just gonna ask our buddy ChatGPT to fix that. Another way is, of course, to use the find and replace function. So I'm over here in my feature studio. I'm gonna hit find. I'm gonna type that symbol. I'm gonna use this to toggle to the very first one. I'm gonna replace it with nothing. So hit replace, 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 replace. I could hit replace all if I was super sure there's not any more of these. I could have done that right here. Yeah, and that's probably as good a way, probably better than asking ChatGPT to rewrite the whole thing. Let's try that. As you can see, we're well into experimentation land here. Okay, the other issue I'm having is I think my previous table didn't have the inch values. And so I had been putting them on at the end here, but now I don't need to. Shouldn't need to. Yeah, there we go. Because the first one, it would have been 4.185, just a number. And this was 4.185 inches. So then when I tried to add inches here, now it's trying to make an area. Go back and see the very first episode on value with units if you need a refresher on that. Okay, bit of a roundabout way to do it. And like I said, I really wouldn't do it here most likely. I guess you could. You could. I'm not going to stop you. I have put tables in, in like nested arrays like I showed in the containers video, and it can be useful. But let's show you how you might do this just in a custom feature instead of having to put it all in. So we'll go to the Feature Studio and I'll show you just a little bit about how to do this. And we can go through how you might declare variables, for the helix angle, for example. We'll put that into a custom feature as well. So to do a custom feature, I'm going to come underneath my imports here, and I'm going to hit this new feature button, and this will be sprocket function. And we don't need anything for the input because we're just going to declare the variable as a function. Realistically, if you're already in here in a feature script and you only need one function, you could put your inputs as user interface fields here and then actually process and just return the result down here. But if I'm going to show you how to make a function library, you might want to include variables for like 15 different functions and just have no user interface at all. You just instantiate the feature and hit the green check, and then your variables are declared. So let's do it that way. To declare a variable, we're going to type set variable. Let's see. Yeah, and we have two options here. That means they are overloaded. This is a function as well. I'm going to include the one with the description. The name will be sprocket size to OD. Size and teeth. I prefer, well, let's just call it sprocket OD. How about that? And then in the description, we'll tell you what goes on. All right, sprocket OD, and the value is going to be function, and the parameters are going to be size and tooth count. And then the contents of the variable, it's going to be return, if you recall, and then there will be closed semicolon there. And we want to first check for the size because that's the first key set here. So we're going to return, we have this table here already. We're going to do that table. I'm going to find size, and I'm going to put it in braces here because the size is a string. The tooth count won't be a string. So it's just going to be easier if I go like this. So that's how we're going to look up our items. So we have, this is the entire table, everything we have. Then we have size, which is going to be these keys, the sprocket size. And then inside of that, we need to get the tooth count, which is all of these numbers. So we're just kind of drilling our way down in this table and returning it. And then I'm going to add a description because if you're doing this as part of a team, you want it to be more usable. It's already a fairly esoteric thing to ask all of your team members to do. So do what you can to help them out and show them what's going on. So I'm just going to write a quick description. All right, we can commit that. And now we're done. So I'm going to go back to my sprocket table here and suppress these just to get rid of the ones that I already had. Sprocket function, this was the name of of our function, and there's no user interface because we didn't put any code there. We're just going to hit the green check. And now that function should be declared. We can see in our variable table whether or not it was. Yes, and there's the description from our custom feature. Variable type. We could even, if you wanted, once again, you could paste the function itself into this description, after this text, if that was helpful. All right, and let's see. We just need to use the actual sprocket function, which was just called sprocketOD. And we actually don't need the table anymore. I had that as an argument in the other one because the table itself was an input, but the table is in the feature, so we don't need it. Cool. I think that works. Yeah. All right. For completeness, I'm going to go ahead and show you how we can add an additional variable in here for our helix angle, just so that you can see how you might declare multiples of these with just one feature and then reuse them across your documents. So we're going to do set variable again. I think the repetition could be useful. The name of this one is going to be a string called helixAngleToPitch. And the value is going to be a function. The parameters are going to be the two arguments, which is helix angle and diameter. And function itself, the body of the function will be return tangent of the helix angle times diameter times pi, semicolon to close that out. I just hit the semicolon before auto-completing. Pi needs to be actually capitalized. It was highlighting for me. There we go. Okay, and if I wanted to, if I used the version of this that didn't have the description, here is where I would add a comma and a description. We'll commit that, and then when we come back to this part studio, you can see that because this feature is at the top, declaring both of those functions, we will have our helix angle function here as well, right there. So that's how you can, in the meantime, but until it's available in Variable Studios, that would be the way that you want to declare them if you're going to use them in multiple places in your organization, which, as I've already said, that's really what functions are best at, is making reusable code. So you really need to package them up and be able to use them in more than one document and Part Studio at a time. Okay, that's it for functions in input fields in Onshape. Let me know how you think you might actually use this. I know that the edge cases are a bit limited, and as of October 25, they don't work in Variable Studios, which is, I think, where they would be most valuable. But I do still think that there are situations where they could be the real best solution for what you're trying to do. So if you find one of those, let me know. I want to hear about it. Text, put it in the comments, and hang tight for the next video where we're going to take FeatureScript in these windows all the way to its practical limit, at least as far as I've been able to explore. It's going to be fun. See you there.